Alright, this week we're going to look at graphing linear relations and its word problems. Our goal this week is to solve word problems using linear relations and graphing. Alright, before we get into the word problem, we're just going to review graphing linear relations. Alright, so last week you were given a table like this, where you had the x value and then a relation related to the x value, which ultimately gave us what our y value was going to be. And then we had to write them in ordered pair, x comma y, right? When we have this table, we don't always have to go up by 1, 2, 3. Okay, it's up to you. You can use whatever numbers you want. So let's say I want to start at 0. Okay, so I'm just saying that x is going to equal 0. X can be anything in a linear relation. Okay, but when x is 0, we look at what y is going to be by plugging in 0 for x. So we have 4x minus 2, plug in 0 for x, and we have 0 minus 2 is equal to negative 2. Okay, so when x is 0, our y is going to be negative 2. So our ordered pair becomes 0 and negative 2. Alright, maybe for the next one I'll pick 2. Okay, so I go 4x minus 2. I use the same relation. We'll figure out what y is going to be when x is 2. This gives us 4 times 2 minus 2. That is 6. So I have 2 and 6 as my ordered pair. Okay, last one, let's use 4. Okay, 4 minus 2 gives us 14. Okay, so when x is 4, our y is 14, so our ordered pair is 4 and 14. Right, so we're going to now graph our ordered pairs on our graph. Okay, so some of you have said that the graph is not big enough for us to graph the relations, but it's up to you to make how you make the axes. Okay, if I go up by 1, okay, if I go up by 1 on the y, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It only gives me room for 10, but I need to go all the way up to 14. So instead of going up by 1, I'm going to go up by 2. Okay, so let's just erase these and we're going to go up by 2. Okay, so this will be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. See how that gives us enough space? Right, but in the y, we also have a negative 2. So we have to go down into our negatives to negative 2. I don't have to fill it all out because I won't be drawing all the way down there. Right, and our x values, it just has to go to 4. Just because we went up by 2 in the y-axis doesn't mean we have to go up by 2 in the x. So maybe here I want to go up by 1. Okay, 3, 4, 5, 6, 7, 8, 9, 10, negative 1, negative 2, negative 3. I won't go any further. Alright, now my job is to graph the ordered pairs. So I have 0 and negative 2. So I go to 0 on x and negative 2 on the y and draw a dot right there. Okay, and then I go to 2 on the x and 6 on the y, and this is where the dot should be. So I draw a dot right here. Then lastly, I have 4 and 14, and I draw a dot right here. Okay, but I'm not done because this is a linear relation. Because 4x minus 2 is what we're given, x can be any value. So it means that I can connect this line and all our and then the relation is represented by the line because x can be any number on the graph. Okay, we just chose 0, 2, and 4 to figure out what points are on this line. Okay, but this line is telling us that is telling us the relationship between the x and the change in y as x changes. Okay, all right, so we have our graph here. Let's go into a word problem. Okay, we're going to take everything we've covered and put it all together. So we went over how to make equations when you're given a sentence. We're going to use that here. Right? So we have Tony's Pizza Place sells medium pizzas for $9 each. You can order extra toppings for $2 per topping. Okay, so we have to first write an equation to show the cost of the pizza, how that is related to the amount of toppings you order. So those are the two things that we're looking at. the relation of cost of the pizza and the amount of toppings that you order. Okay, so let's actually give them each a variable. So cost we can say is C, and amount of toppings maybe we can say is T. Okay, so looking at the information that's given to us, we have to pay $9 for the pizza all the time. And on top of that, we have to pay for every topping that we add. And per topping, it's going to cost us $2. So we go 2 times T. Okay, and that's going to give us the total cost of pizza. Okay, so again, we have $9. That's the flat rate for a medium pizza. And then we're adding $2 for every topping that we add. So we go 2T. Okay, and when we add them together, we get the cost of the whole pizza. Okay, and that is our equation. Okay, so topping is our independent variable and cost is our dependent variable. The cost depends on the topping. Okay, so for cost, we can say that this is also equal to 9 plus 2T. Okay, so for toppings, we can put in anything we want, right? So we can say, what if we don't add any toppings? If we don't add any toppings, it's just going to cost us $9. Okay, what if we add 5 toppings? If we add 5 toppings, we're going to go 9 plus 2 times 5, 9 plus 10, that's going to cost us $19. Okay, and then for, let's say 10 toppings, we're going to go 9 plus 2 times 10, that's going to give us $29. And for 15 toppings, we go 9 plus 2 times 15, that's equal to 9 plus 30, and that's a total of $39. Okay, now what we're going to do with this is we're going to graph it. Okay, so it's the same thing. These become our ordered pairs. So 0 and 9, 5 and 19, 10, 29, and 15, 39. Okay, and our toppings is going to go on our x-axis because these are the independent variables, and cost is our dependent variable. It depends on the number of toppings. That's going to go on our y-axis. Okay, so looking at that, it looks like we have to go all the way to 40. So I'm going to make my axes 0, 10, 20, 30, 40. Okay, and the toppings, maybe I'll go 5. Let's go 10 up by 10 again. Let's skip a place. 10, 20, 30, and 40. In this case, you don't have to extend your graph out to the negatives because you can't have negative number of toppings, right? So this will be voided. And the cost, you can't get paid for buying the pizza if it's $9, right? So this will not be applicable here. All right, and I just have to graph it. So for 0, it's going to cost me $9, so just below 10. For 5, it's going to cost me just before $20. For 10 toppings, just before $29. For 15 toppings, just before $40, $39. And that is my linear relation. It's going to go up like this. Okay, in word problems, we're not done. We are also going to use this information to estimate how much will the pizza cost with 6 toppings. So what you're going to do here, you're going to look at your graph and you're going to go, okay, so actually I forgot to do one thing on my graph. I had to label my axes, right? So our x-axis told us the number of toppings. Okay, and then the y-axis was the cost of pizza. Okay, so let's write that down here up on the side. Label your axes. Okay, this is important. Alright, so how much would it cost for 6 toppings? I'm going to go to my graph and I'm going to read the graph. Okay, I'm going to read on the x-axis is where it tells me the number of toppings. I'm going to go to 6 and I'm just going to move up to my graph, and it looks like it's going to cost me just over $20. So I'm just going to say for this question, it will cost me approximately $21. Okay, and then you can confirm this by using your equation. 9 plus 2 times 6, 9 plus 12 gives us 21. And it is correct, right? So here we use a graph to approximate a And then we use our equation to confirm our total cost of the pizza with 6 toppings. All right, and then E says if the total cost of the pizza was $33, how many toppings were ordered? We go to the total cost of pizza on our y-axis and we go to 33. Okay, and 33 is going to be somewhere around here. And then on the graph, this shows us that's going to be around 11 to 12 toppings. Okay, so we're going to say around 11 or 12 toppings. And to confirm, we're going to use our equation, which was C is equal to 9 plus 2t, and cost was 33. So we substitute 33 for C, and we have to look for what t is. Let's take away 9 on both sides. 2t is equal to 24. And then divided by 2 on both sides. T is equal to 12. So it looks like 12 toppings is the correct answer. Okay, so depending on how you drew your axes on your graph, you might be able to get these values right away, okay, without estimating. But if you use axes something like mine, you're gonna have to estimate. Okay, once you estimate it, you're gonna go back to your equations and make sure your estimations were close. Okay, hopefully you're not too far off when you use the equations to solve. Okay, but the goal of this week's lesson is for you to use a graph first to solve questions like these. Right? So in order for you to solve these questions, it makes it easy for you if you have the axes labeled. Okay, so number of toppings is on the x. That's why I knew to read from the x-axis when I was answering this question. And then cost of pizza was on the y-axis. So for this question, that's how I knew to use the y-axis to read the graph, sorry. Okay, so for this week, you're going to complete a quick task that goes over some word problems, and there is a quiz on D2L as well. All right, have a great week.